So I will now extend this code to create a three-dimensional plot. Okay, I'm going to collapse this, create a new section. And this will be called vectors in 3D. So I'm introducing to this code because we're going to later use this for more advanced examples. Okay. Let me just copy the code. So these are the same functions we saw before, but for 3 dimensions. Same as before, but now we have a z-axis or a linear space for the points along the z-axis. And of course, we're now adding a third list in this tuple. So the points on the 3 axes. It's the same function, just adapted for 3 dimensions. And if I want to create one vector in this 3-dimensional coordinate system, so for example, 10 on the x and y and z axis, we would get something that looks like this. Let me copy the figure information. All right. So this is the x-axis. You can see if we look at it from the x-axis, if I follow this gray line, if I go all the way here, it is 10 points away from the x-axis. Okay, it's maybe here. Then on the y-axis, same thing. On the y-axis, and of course the z-axis. So you kind of have to imagine this is in a 3-dimensional space, right? And of course we can plot a second one. Let's change this to 20 on the z-axis, for example. So going forward, we're going to use this code to draw vectors in either 2 or 3 dimensions. Okay, so the orange one, obviously, second vector, it's higher on the, and now this one goes up to 15. So let's make these point on the z-axis 15. Okay, so going forward, we're going to use this source code. Now, let me show you practical example. But now with vector addition, because I think outside of physics, I can't come up with any practical example. So I'm just going to turn our attention to the polar coordinate system. We will talk about the polar coordinate system, the magnitude of a vector. And then once we have the magnitude, we will also look at scalar multiplication. And then once we've covered these 3, so the polar coordinate system, magnitude of a vector, scalar multiplication, and then we can implement cosine sum. It would be cool to plot the rotate space. Yeah, we want, there's a great library, but not Matplotlib. Matplotlib is flat. If you want an interactive one, there's something called, I think Seaborn does it, but there's also one called Plotly. I really like this library. So if I go to Plotly for Python, let me just Google Plotly 3D plot. It's a very simple to use library when it comes in JavaScript. So, you can create, this is the one. This is very cool. You can take snapshots of it. You can take, that's a snapshot. You can zoom in, pan. And maybe I'll give you the source code for using this library. It's pretty straightforward, by the way. Nothing spectacular. It's very analogous to matplotlib. So the same convention, you need a data frame. So this is going to be the list of values, and then so df stands for data frame, and the data frame is simply a table, x and y points. So the left column would be the x points, y column would be the y points. Yeah, and you can also have like a heat density. It's a bit finicky to play around with, but this is one option.